Welcome back, everybody. Let's solve questions on circle geometry now. We go straight to it. The first one is A. In the diagrams, wherever O is written, it is the center of a circle. Now let's go. Here Q is at the center and 41 degrees is at the circumference. So that simply means Q is 2 times 41 degrees. And the rule here is angle at center equals twice angle at circumference. Now to B, very quickly, R is at the circumference and 106 degrees is at the center. That simply means R is 106/2. By the same rule, angle at center equals twice angle at circumference. That means angle at circumference is half of angle at center, and that's 53 degrees. Now to the next, which is C. S is at the center and 126 is at the circumference. That simply means S is 2 times 126 degrees, and that is 252 degrees. Angle at center equals angle at circumference. Now to D, we want to find angles T and U. First of all, angle T is twice angle 135 degrees. T equals 2 times 135 degrees, and that's 270 degrees. Angle at center equals twice angle at circumference. Now U plus T is 360 degrees. The whole of this is 360 degrees. That's some of angles at a point, and that simply means U will be 360 minus T, which is 360 minus 270, and that's equal to 90 degrees. Now to E, here we can see that angles, first of all, angles W and 32 are in the same segment. If I do this, divide the circle into two segments this way, this is what I'm going to see. This is one segment. If this is one segment and this is another segment, this is another segment. The first one is a minor segment and this one is a major segment. Would see that W and 32 degrees are in the same segment. W and 32 degrees are in the same segment. We must take note that those angles in the same segment must be at the circumference and not just anywhere in that segment. So I'm looking at 32 and W, which are at the circumference of a circle and not V. I won't say that 32 is also equal to V. No, because V is at the center. So now W equals 32 degrees. Angles in the same segment are equal. V will be 2 times 32 degrees. Angle at center 2 times 32 degrees, which means angle at center equals twice angle at circumference, and that's 64 degrees. Now to the next very quickly. And that's question F. F is, and I'll bring that. Now this is F. It says we can see that angles 119 degrees and X are center and circumference angles. We must take note here, this one is facing up and the X at the center is also facing up. The angle at the circumference and the one at the center that are related by that rule that says angle at center is twice angle at circumference must face the same side. So it is y and z that will also be center and circumference angles. So 2z will be y and 2 times 119 will be x. So x equals 2 times 119 degrees. Angle at center equals is twice angle at circumference, and that's 238 degrees. Now double y is equal to 360 minus x, which simply means 360 minus 238 degrees. And the reason for that is that angle at center, the sum of angles at the point is 360 degrees, and that's 122 degrees. Now to z, we know that y is 2z. That simply means z angle z is y over 2, which will be 122 divided by 2, and that's 61 degrees. Now to the next. Number 2 says, in the diagram below, P, R, and S are points on a circle center O. If POR is 150 degrees, calculate PSR. If POR is 150 degrees, calculate PSR. Let me bring the diagram first of all. Now this is the diagram, and that's number 2. If POR is 150 degrees, calculate PSR. Okay, that's supposed to be simple. If this is 150 degrees, then it means this is going to be 360 minus 150, which is 210 degrees. Now, if that's 210 degrees, that simply means PSR will be half of that. Angle PSR is half of 210 degrees. Angle at center is twice angle at circumference, and that's 105 degrees. Now we go straight to the next, number 3. P, Q, and R are points on a circle center O. If OPQ is 36 degrees, what is the size of angle PRQ? Now let me copy the diagram. Now this is number 3. If OPQ is 36 degrees, what is the size of angle PRQ? So we want to find the size of this angle. Now that's supposed to be easy. OP and OQ are radii. That means triangle OPQ is an isosceles triangle, and it means this will also be 36 degrees. Now if OQP is also 36 degrees, it means this will be, we know that 36 plus 36 plus this angle is 180 degrees. So that means angle POQ will be 180 minus 72. 180 minus 72 degrees, and that's 108 degrees. That means this is 108 degrees. If you add this and this angle together, you get 180. So angle POQ is the same as 180 minus the sum of angles OPQ and OQP, which means 180 minus the sum of this angle and this angle, 36 plus 36, and that's 108 degrees. That simply means angle PRQ is going to be half of 108 degrees. Angle at center is twice angle at circumference. PRQ 2 times PRQ is the same as POQ. So PRQ will be half of angle POQ, which means 108 divided by 2, and that's 54 degrees. So that's it quickly. Now to the next, which is number 4. Number 4 says, Find the lettered angles in the diagram below. O is the center of each circle. Now we go straight to that. Let me copy question A. That's 4A. That's 4A. Find the lettered angles. First of all, W equals 180 minus the sum of angles 21 and 90 degrees. And the reason for that is angles in sum of angles in a triangle. 180 minus 21. 180 minus the sum of 21 and 90. That's 180 minus 111, which is 69 degrees. Now the next is, how do we find angle Z? Okay, let's see. This looks a bit tricky, but it's simple, I'm sure. Okay, yeah, W plus Z. W plus Z is 180 degrees. Sum of angles, opposite angles of a cyclic quadrilateral are supplementary. This is a cyclic quadrilateral 1, 2, 3, 4. All its vertices are on the circumference of the circle, so its opposite angles are equal. W and Z are opposite angles of that quadrilateral, and their sum is 180. That simply means angle Z equals 180 minus W, which is 180 minus 69, and that's going to be 111 degrees. 180 minus 60 is 120, minus 9 is 111 degrees. That's angle Z. Now angle Y is double angle Z, so that simply means Y equals 2 times Z, and that means 2 times 111, which is 222 degrees. Now angle X plus Y is 360 degrees. Angles at the point, because O is the center of a circle. So that simply means X is 360 minus Y. X equals 360 minus Y, which means 360 minus 222. 360 minus 222, and that's 138 degrees. The next one is, and that's all. We found W, X, Y, and Z. Okay, let's pause it and then we'll continue. Oh, let me finish the whole of number 4 before we take a break. Now number 4B. Now this is 4B. We are finding the lettered angles. First of all, A is 180 minus 134 degrees. Angles on the straight line, and that's 46 degrees. Sum of angles on the straight line, E plus 134 is 180 degrees. Now angle F is twice angle E. Angle F equals twice angle E, which is 2 times 46. Angle at center equals twice angle at circumference, and that simply means F equals 92 degrees. Now angles G and H are equal because they are base angles of this isosceles triangle. This is a radius, this is a radius, and this is also a radius, so that means these angles are equal. So angles G and H rather are equal. So I can say that means I can simply say G. I think I need to bring the diagram down so that we can see it to be able to find angles G and H. Let me paste it here. Yeah, this is the diagram. Now G plus H plus F is 180 degrees, sum of angles in a triangle. Since G and H are the same, so I can use G for both. So that means G plus F equals 180 degrees, and that means 2G plus F. We already know that F is 92 plus 92 degrees equals 180, and that means 2G equals 180 minus 92, and that means 2G is 88 degrees, and G will be 44 degrees. So that simply means H is also 44 degrees. Now to the next, which is C, which is 4C. Bringing that here, 4C. 4C. Now angle D. Okay. Oh, it looks like no value was given here. Number 4C. The question says find the lettered angles in the diagrams below. How do we find that? 4C. No value was given. Let's see. I hope I copied the question correctly. For C. Okay, I think I'll check that later. It's possible I omitted something in the diagram. So let's go to D, which is the last one under number 4. Now I'll check 4C later. Now D. O is the center of a circle, and we're finding angles U, W, V, and T. Those are the angles we're finding. So now, first of all, triangle PQR is isosceles. That simply means angles V and W are equal. These angles of an isosceles triangle are equal. Now, first of all, T will be 81 plus 53 plus T equals 180 degrees. That means T is 180 minus the sum of 81 and 53 degrees. And that simply means 180 minus the sum of 81 and 53 degrees, which is 46 degrees. That's 180 minus 134. And that's 46 degrees. Now that we know T, we can also see that T and U are opposite angles of a cyclic quadrilateral, and the cyclic quadrilateral is SPQRS. So angles T and U are opposite angles of the cyclic quadrilateral SPQRS. Cyclic quadrilateral SPQRS, and that simply means U will be, that means U plus T is 180 degrees, and U will be 180 minus T, which is 180 minus 46, and that's 134 degrees. That's 134 degrees. Now that we know U, we know that V and W are the same. So that means U plus W plus V is 180. U and W are equal. As you can see, they are the base angles. They are the base angles of the isosceles triangle PQR. So I can use one letter for both of them, the same letter. So let me say U plus V equals 180. And that simply means 2U plus 134 equals 180. Which means 2U equals 180 minus 134. And that means 2U equals 46 degrees. And U is therefore 23 degrees. Which means W is also 20. U is 23 degrees, and that means W is also 23 degrees. So that's it, very, very simply. Let's stop there and continue. Let's take a break and continue in a few. Thank you very much and stay blessed.